Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khaldi explaining how to find square roots of complex number in algebraic form. You can use this formula of square roots of algebraically by writing a square root of a plus bi, like this. Square root of a for real plus bi for imaginary. Remember, I is under the root, so you can use this formula easily. A square root of z will give you two solutions, which are plus and minus. Plus and minus, square root of r plus a divided by 2. R is going to be the modulus of the complex number, which can be calculated easily by this way. The modulus of z, which is the same as r, which is the square root of the real part all squared plus the imaginary part all squared. Then you can replace it instead of r. Plus and minus, square root again of r minus a divided by 2. And don't miss I here for the imaginary part. That can be written in another way by writing plus and minus square root of the modulus instead of writing r, which is the same, plus the real part in general divided by 2. This all under the root. Plus and minus square root of the modulus minus the real part divided by 2. This plus and minus in the middle, you have to take care about it, because if here you have a plus, you can write a plus in the middle. And if it is minus, you are going to use minus in the middle. You are not using both. Again, if you have a plus in the middle, you have to write here a plus in the middle. And if it is minus in the middle, you have to write minus in the middle. This is for the complex number and how to find the square root of the complex number algebraically. Now, to help you to find r easily without using this rule, this nice rule, you can use Pythagorean triplets. Look, if you can have 3 for real and 4 for imaginary, or the opposite, we don't care, with positive or negative signs, you can find r by this rule. Here, this can be plus or minus, and also this can be plus and minus. It doesn't matter, because if you are going to use r, it can be easily square the real part and square the imaginary part, and that will cancel the positive or the negative. So here, r can be calculated by using this rule. 3 squared plus 4 squared. That will give you r equals 9 plus 16, which is under the root of a 25. So r will give you 5, which is here exactly. R equals to 5. So without doing this long story or this formula or this rule, you can quickly, if you have 3 and 4, say that r equals to 5. And if you have 5 and 12, you can say r equals 13. We don't care about if it is positive or negative, if it is real or imaginary. If you have 8 and 15, you can make r 17. 7 and 24, r always can be 25. A note for you saying that a and b and c is a Pythagorean triplets. Then if you multiply any one of them by any number, like n is also Pythagorean triplets, where this n can be any positive integer number. Like, for example, here in number 3, if in the first one, if you have a 3 and 4, and you need to multiply them by 2, for example, that will make it 6 and 8. And you should multiply also by 2r, and that will make r equals to 2 times 5, which is 10. So this is a new Pythagorean triplets can be used. Now let's apply this rule by using the following exercise. The first exercise is saying, write true for the true statement and false for the false one. And in the first one, you can see that the number 3 minus 2i is a square root of 5 minus 12i. An advice for you, translate what you read by writing it in this way. Translate it first, because it looks like a word problem. And this statement needs from you to understand it well, because most of the students doesn't know where is the number that we need to find its square root, and where is that square root. So I prefer to translate it. If you're going to read the number, so start writing it. 3 minus 2i. The word is make it equal. Square root, make a square root of, make it inside. Like this exactly. 5 minus 12i. Now you have two choices. You can square both sides and get rid of this square root, or you can use the formula. I will do both. If I will square both sides, I will get exactly like this. Square both sides. Both sides. By making 3 minus 2i all squared equals to a square root of 5 minus 12i all squared. That will let us get rid of the square and the square root and use a rule for the perfect square here, which is real part squared 9 minus always the imaginary part is squared, which is 4. All can form or make the real part. Then plus always between the real and the imaginary part. You can write 2 times the real part, which is 3 times the imaginary part. Take care about its negative, if it has. And then the I. This all how to expand the left side, which is the perfect rule. Equals 5 minus 12i. Now if we get, or we proved that the left side is equal to the right side, that means the statement is true. 9 minus 4 is 5, plus in the middle, 3 times 2 is 6, 6 times negative 2 is negative 12 with an I. And that will be similar to what do we have in the right side, which is 5 minus 12i. So I can say that this statement is true. Let's go to the second. The number 3 plus 4i is square root of 7 plus 24i. You can do it like I did before, or you can use the quadratic formula. Or what do we call it? Sorry, not the quadratic formula. What do we call it? The formula that we have here above in the box, in this box. So let's use the formula, not the squaring both sides. That will be easy if you gonna say that square root, or translate first. I prefer to translate first by writing 3 plus 4i means equal square root of 7 plus 24i. So I will do or work on the right side by finding the square root by the formula. I have a plus and minus in the formula, and I need to make a square root in a bracket here including r. We're gonna go here to 7 and 24. 7 and 24 will give you r25, easily to be used from the triplets. 25 plus the a, and the a here is 3, as you see. So let's use this 3 here. That all divided by 2. And because we have in the middle plus, so we are going to use this plus in the middle, which is going to be here. And again, write this square root, including 25 again, but minus 3 all divided by 2. Don't forget to write the I for the imaginary part. That's it. Now try to calculate. You can find the values under the root by adding 25 plus 3 divided by 2, which is gonna be 28 divided by 2, 28 divided by 2, which is 14. Here plus square root of, here 25 minus 3 is gonna be 22 over 2, and then I is outside the bracket, and that will give you something different than a 3 plus 4i. So because of that, the statement is gonna be false. Now let's choose the best alternative, and that will be easily with the first question. The two square roots of 3 plus 4i are. If you want to choose the correct answer by squaring each of the alternative, you can, but be sure to square only the one which has positive in the middle. Don't choose that one which has negative in the middle, because the middle sign should be similar to the middle sign here. So you can square this one and this one. But if you would like to use the formula, you can also by using square root of 3 plus 4i, and making a plus and minus, open a bracket, write a square root of. According to the triplets, you know that r is 5 plus 3 all divided by 2. And here a plus because we have a plus in the middle, and I for the imaginary part, and this all supposed to be outside the bracket, like this. Plus here outside, and I square root of 5 minus 3 all divided by 2, close your bracket. Now try to calculate or evaluate what you have. 5 plus 3 is 8 divided by 2. That will give you 4. And square root of 4 will give you 2. So you can say it's 2 plus, also 5 minus 3 is 2 divided by 2 is 1. And this will be 1i. So I can write it I only. So this is the answer, which is 2 plus I. So I can choose the second alternative, and this is good. Now you can go to number 2, which is saying the 2 square roots of 15 minus 8i are, by using also the 2 choices. Here I can think about the one which has negative, not the one which has positive. So I will think about this one or this one, and ignore this one and this one. So you can square them if you would like to without using the formula, and know which one is the right answer, or you can use this formula. Square root of 15 like this minus 8i. That will be positive and negative. Square root of, inside the bracket, 15 and 8 with the triplets will give you 17 here. So you can use the 17 instead of r. So you have 17 now plus the a, which is 15 divided by 2. Because you have negative in the middle, use negative with the I. Square root again 17 with minus 15. And this all will be divided by 2. Close your bracket and continue. Plus and minus again, and you will have square root of 17 plus 15 is gonna be 32. And 32 divided by 2 is 16. So you are finding a square root of 16, which is 4. Square root of 16 minus I. 17 minus 15 is 2 divided by 2 is 1. So no need to write this one. Then continue by writing plus and minus. Square root of 16 is 4 minus I. So we are going to choose the second choice, not the last, which is gonna be this one. In number 3, we can see that the two square roots of the complex number for 2 plus 2 root over 3i. The problem here that I don't have the triplets for this. You have two choices. You can take it to outside as a common factor and find the modulus easily, or you can calculate it by using this rule. The modulus of z equals to square root of the real part, which is 2 squared, plus 2 square root over 3 all squared. That will give you square root of 4 plus 4 times 3. Now try to multiply first, then add. 4 plus 12 will give you 16, which is 4 finally. Now you have the modulus, which is r. You can use it now by finding the square root of 2 plus 2 root over 3 with an I. This will give you plus and minus, open a bracket, square root of. The modulus is 4. You're going to add to it a, which is 2, divided by 2 always. If you have positive in the middle, make it positive. And don't forget I for the imaginary part. Now take this 4 and minus it by 2 again, divide by 2. Close your bracket and you try to do it by calculating them. Plus and minus again, 4 plus 2 is 6, divided by 2 is a 3. So this 3 is not a perfect number, so it stays under the root as a perfect square, as a square root of a 3. Plus I here multiplied by square root of 4 minus 2 is 2, divided by 2 is 1. So close your bracket. You will get the answer, which is gonna be the one which has positive in the middle, root over 3 plus li, which is the second. We can't choose the first because it has negative in the middle. So take care about the sign in the middle. Now, in number 4, we can see that we have to find one of the two square roots of the complex number, which is negative 2i is going to be. If you would like to use the formula, you have to know that a is equal to 0. So here, if you have a square root of negative 2i, you can say that I inside the root is telling you that no a here. So a, which is the real part, is 0. So if you would like to use the formula, you can by using a plus and minus. Open a bracket like this and write in under the root 0 instead of r plus, no, we are going to write r. R is going to be 2 because the modulus for this is going to be 2. So you can start by writing 2 first, which is instead of r, plus the 0, divided by 2, and that will give you 1 finally. Because you have negative here with the imaginary part, so write minus. And this is our I, which is the imaginary part. Square root of 2 again for the modulus, minus the 0, and no need to write the 0 finally. And that all can be closed to give you plus and minus. Here, open a bracket and write inside it 1 minus I. So the answer is gonna be 1 of the two square roots. He didn't ask for finding 2 of them. So you can choose one of them, which is gonna be the first choice, plus 1 minus li. And this is the end of this question. But I would like now to write for you some formulas can help you to find the work easily. Here I can write them for you. If you have, for example, any square root of a plus bi with positive, you can use it easily by writing positive and negative, open a bracket, square root of the r, which is the modulus, plus this a, divided by 2, and if you have positive in the middle, you can write positive and then use I for the imaginary part. Repeat what you wrote, but write r minus a all divided by 2, close your bracket. The second, including a minus bi. That will make it positive and negative again. Open your bracket and write r plus a divided by 2, and instead of writing positive, you have to keep it negative, similar to the sign of the imaginary part. And I multiplied by r minus a divided by 2, close your bracket. Now if you have an imaginary, pure imaginary number, like for example minus bi, that means a is 0, so it is easier for you to start by plus and minus, open a bracket, without a bracket. Here you're going to open your root, writing b divided by 2, b divided by 2, and then open a bracket, including 1 minus I if you have negative here. And if you have positive for this pure imaginary number, you can write positive and negative for all, and a square root of this b divided by 2 as a common factor multiplied by 1 plus I. That can help you to get the answer easily. Good luck for you. Thank you for listening.